Sound. Reflection of sound. Like any wave, a sound wave doesn't just stop when it reaches the end of the medium or when it encounters an obstacle in its path. When a wave reaches the boundary between one medium and another medium, a portion of the wave undergoes reflection and a portion of the wave undergoes transmission across the boundary. Reflection of sound waves off surfaces can lead to one of two phenomena: an echo or a reverberation. To hear echo and reverberations, click on the buttons below. Our brain retains a particular sound for a fraction of a second, precisely 0.1 seconds only. Now, taking this into consideration, the reflected sound must reach our ear within 0.1 second of the initial sound, and then it seems to the person that the sound is prolonged. The reception of multiple reflections of walls and ceilings within 0.1 second of each other causes reverberations, that is, the prolonging of a sound. Smooth walls have a tendency to direct sound waves in a specific direction. So, the use of smooth walls in an auditorium will cause spectators to receive a large amount of sound from one location along the wall. There would also be one possible path by which sound waves could travel from the speakers to the listener. For this reason, auditorium and concert hall designers prefer construction materials which are rough rather than smooth. Reflection of sound waves also lead to another phenomenon called echoes. Echoes are different than reverberations. Hear the difference between reverberation and echo. This is an example of echo. This is an example of reverberations. Have you been to any of the old monuments and tried to hear the echo? You say a word and get to hear repetition of that word for a number of times. It is interesting to note that echoes occur when a reflected sound wave reaches the ear more than 0.1 second after the original sound wave was heard. If the elapsed time between the arrival of the two sound waves is more than 0.1 second, then the sensation of the first sound will have died out. In this case, the arrival of the second sound wave will be perceived as a second sound rather than the prolonging of the first sound. There will be an echo instead of a reverberation. Ever wondered why do the tombs and other historical monuments have a dome shape? Well, that is because reflection of sound waves off its surface is also affected by the shape of the surface. Flat or plane surfaces reflect lesser amount of sound waves. Curved surfaces with a parabolic shape have the habit of focusing sound waves to a point. Sound waves reflecting off parabolic surfaces concentrate all their energy to a single point in space. At that point, the sound is amplified. A few other examples of multiple reflections are megaphone, horn, and stethoscope. Let us revise what we have learned. Waves exhibit different behaviors when they come in contact with an obstacle. Example is that the waves deviate or penetrate, refract or reflect. If the reflected sound waves reach our ear later than 0.1 seconds after the initial sound has faded off, then we experience a phenomenon called echo. That was all for now. See you soon. See you soon. See you soon.